So you can tell just by looking at an equation without graphing it necessarily if it's growth or decay. So the B value in your equation is actually what is the growth or decay factor. Your base is that single value attached to your exponent. So when the base is larger than 1, greater than, it's going to be growth. Now, I put absolute value bars around that B because we don't necessarily look to see if it's negative or positive. It's just the absolute value of it. So whether it's a -6 or a +6, and actually let's do something that doesn't look like a B. So say you had -3 to the x or +3 to the x. They would both be growth. So it doesn't matter if this is negative or positive, as long as the number itself is larger than 1, it's going to be growth. So it's going to be decay when that base value is smaller than 1 or less than 1. So let's go down here and look at some of your examples. So first you need to be able to identify what is the base. So the base is what's attached to your exponent. And we can even go through and highlight the base, maybe, in each problem. So the exponent is here. So your base is the 5. Your exponent is here. The base is the 3. Exponent is x, base is 7/3. Exponent is x minus 1, base is the 5. 4/5. Number 8, -3 times 2 to the x. Your exponent is the x, so the base is your 2. Y times, or y equals 1/2 times 8 to the x, the 8. Here it's the 1/2. The 5, the 1/3, the 0.5, and the 4/5. So whatever is your exponent, sometimes it's in the front, sometimes it's in the beginning, or in the back, but whatever that exponent is, the number attached to that is the base, and that determines if it's growth or decay. So number 1, y equals 5 to the x. 5 is larger than 1, so this is going to be growth. 3 to the x minus 6. 3 is larger than 1, so it will be growth. 7/3. First off, don't be confused because it's a fraction. It's a fraction larger than 1, and it doesn't matter about the negative. We don't care. We don't care if it's negative or positive. That will tell us which way it goes, but the 7/3 itself is the part that tells us this is going to be a growth function. 5 to the x minus 1 is growth. We have a lot of growth functions here. 3 times 1/2 to the x. 1/2 is smaller than 1. So that will be decay. 1/2 times 8 to the x. It's not just the number in the front. The 1/2 is not what you're looking at. It's whatever is attached to that exponent of x. So 8 is larger than 1. So growth. -3 times 2 to the x. 2 is larger than 1. 4/5 is smaller than 1, so decay. -5 to the x, same thing again. That negative doesn't do anything for being growth or decay. It's just the value, the absolute value of the base. So 5 is larger than 1. So growth, 1/3 is smaller. Decay. In this one, number 9, we have a 0.5. Yes, it's negative, but that doesn't tell us if it's growth or decay. The 0.5, which is smaller than 1, is what tells us that it's a decay decay function. And then number 12, 4/5 is the base to that exponent. So 4/5 is smaller than 1, so decay. So without having to graph it, you can determine right from the equation if it's going to be growth or decay. If it's larger than 1, growth. If the base is smaller than 1, decay.